chance to do a little bit more. I don't remember how much more I'm going to get. Pretty much just percents. We'll also see percents show up. It's just another conversion factor. So percents are a fancy way of introducing a new way to relate two different species. Okay? We're going to relate one quantity to an overall sample. So you see this in your class. Okay? Your grade is how many points did you get per the possible total. It's a percent. We can apply this into chemistry as well. We can look at how much of a particular element is in a compound in comparison to the rest of the compound. So our percents give us some extra information and allow us to convert things. One of the interesting issues when it comes to a percent is when you look at a value, okay, if we say it's 90% copper or 90% gold, what's the unit on that? It's kind of odd. It ends up happening that your percents are typically reported as unitless. The units cancel out. Becomes a bit problematic when you're trying to use the percents to do something. Turns out percents are not unitless, despite what your textbook says. Okay? Your percents need to get reported with an extra bit of information. It's not 20% copper, it's 20% copper by mass. What does that mean? If I have a 100-gram sample, 20 grams of that are copper. Okay? So what we're looking at is that by mass or by volume. Those are the two common ways to report percents. If that information is not provided, I think the standard is by mass. Okay? It is definitely kind of a confusing concept. It's almost always something I've got to look up, okay, to determine what someone was specifically trying to imply, if it was by mass or by volume, because that can make a really big difference. Okay? So let's take a look at an example. Bronze is an alloy of copper and tin. So an alloy just means we took copper atoms and tin atoms and we mashed them together in a particular order. That order changed the overall properties of that mixture, and we end up calling it an alloy. Okay, so bronze happens to be a mixture of copper and tin. If a sample of bronze contains 79.2 grams of copper and 10.8 grams of tin, what is the percent copper in bronze? Okay, so what we're asking is the mass of copper in the total sample. So to calculate, what's the mass of copper? Does the question give us that information? Yeah. It is 79.2 grams. What is the mass of the total sample? 79.2 plus our 10.8 grams. Oops. Grams of our alloy, or galloy. One laugh was enough. Sometimes that's all you need. Go through, we could punch it into the calculator. What do we get as a number? Anybody got it for me? I always forget the one last thing that we want to do. To report it as a percent, we'll always multiply by 100%. The answer that we get will be 88 point. I actually don't know the next number, so I was hoping you'd help. Oh, it's just 88? Oh, okay, well then never mind. So we get 88 is the number being spit out by the calculator. What do we report as our answer?
88%.
Really? 88%. Everybody agree with that? Oh, is a good pause on that. To report your final answer, what do we have to take into consideration? Significant digits. When we go through and evaluate, what we're doing here is 90.0. How many sig figs in our denominator? 3. How many sig figs in our numerator? 3. What's our answer? 3 sig figs. I only see 2. How do we get 3 sig figs in that? 88.0%. We now have the percent copper by mass in bronze.
So do we have to find it? That's 5 million?
No, on a multiple choice, we'll just leave it as the percent. Just realize that that by mass or that by volume should show up when you do a calculation. Okay. The last one we'll end on is the tin in 100 grams of bronze. So what we're trying to do is figure out the mass of tin in an alloy sample. Did you say 12? Was that the answer? Wow. Oh, no. I know where you're talking about it. Yep, never mind, you're right. Cheated. How much tin is in 100 grams of bronze? So what we're trying to do is figure out the relationship between tin and a larger sample. So what we would need first is our percent of tin in our sample. So to do that, we could take our 10.8 grams of tin and our total 90.00 grams, no, that was right, 90.0 grams of our alloy. Okay, there's our percent tin in the sample. We are in our alloy. We now want to figure out how much is in this new 100 gram sample. How do we incorporate that 100 gram sample? Well, 100 grams. 100 grams of our alloy. What happens with our units?
Cancel.
Our units cancel. What do we get as our answer? We get grams of tin. There's our final answer. There are other ways to approach that with the previous information. If we know it's 88% copper, what's the percent of tin? Has to be 12% to make up to get to our total 100%. Okay? So we didn't have to do this calculation. We could convert it, say we were at 12%. Whenever we use our percents in our calculations, you notice that this does not equal a percentage. We look at just that, right? We punch that into a calculator, we'll get 0.12. If we're going to use a percentage, we must use the decimal version of it, not the percent version. Okay? That is time, so we'll go ahead and end that. If you've got questions, come up and talk to me after.